All right, welcome everyone to our April community meetup. We have a really good agenda for today. So we'll start off with the usual community celebrations. We'll do some product updates, Tal. We're gonna look at the cloud beta demo, which is brand new from Eric. And then we're lucky to have Tamara here from Astronomer to talk about what's next with GX and Airflow, a new Great Expectations operator. And then lastly, Ruben will go into some of the top questions of the Great Expectations community. Then we'll wrap it up. All right, so I'll get it started. Okay, so we're still hiring. There are a couple positions open, senior software engineer, we for both open source and cloud, and then also senior developer advocate position. So again, if you have any questions about these roles, you want to learn more about the company, feel free to reach out to me or anyone from Great Expectations if you want to talk more about these positions and what it's like to work here. All right, moving along. So some of the project and community stats. So we crossed 10,000 Slack members, really exciting. We added 288 since the last time that we met. Really cool to see us break 10K. I know, like, round numbers, whatever, it's exciting. Just point out a big round number and get excited about it. But yeah, really cool to see that. All right, moving along. Our PyPy downloads are sort of staying at a steady rate here. Seeing 8 million and 8.8 million last month. That's a ton. It's a bit less than the month beforehand, but still a bunch. This one data point still super confusing. Just a zero one day. Everybody took off on this day. All right. I want to say thank you to all the people helping in Slack. It's really great to see others helping one another, especially, we're seeing we're at 10K people in the Slack community. So we really need everyone to pull their weight and help one another. It's almost impossible for just a few of us to answer all the questions. So shout out to all of you again for helping us in Slack. All right, I'm going to hand it over to Tal, and Tal, I can run the slides for you from here, or if you want to take over, that's fine.
Yeah, just these couple, I think. Yeah, so just wanted to say thank you. We had a ton of great contributions over the last few weeks. Wanted to give a specific shout out to Mayan God, who added support for Date for the row condition parser. So this is making it possible to use Date within conditional expectations for SQL Alchemy. And also a shout out to Mantas Michaelides, who added a new custom query expectation. So this is expect queried custom query to return number of rows. And so you're able to basically pass any query to the expectation and also pass the expected number of rows, which is just a really cool thing. And as part of that expectation, there's also some modifications made to, like, the infrastructure behind query expectations. So it's just always really great to see contributions like this. So I wanted to give a specific shout out there. And then, yeah, if we move to the next one. Yeah, but again, we got a ton of amazing contributions and a bunch of contrib expectations, a bunch of new expectations, a bunch of support for new backends for existing expectations. So it's amazing to see this. Thank you so much, everybody. So
all right,
I think I'll roll right into some product updates. Great. So we've launched our GX Cloud Beta. So we're really excited about that. You're going to see more on that later from Eric. So I'm not going to spoil any of the fun, but this is really exciting. And also, I just wanted to remind you of just our commitment to open source. And so we have a whole bunch of really exciting things coming up for open source. So we're adding support for SQL Alchemy v2, support for Pandas v2. And then we're also making improvements to the SDK to make it easier to write and contribute data assistance. And then we're always just making continued improvements to testing and infrastructure for OSS Great Expectations. So yeah, thank you. That's an old slide.
Okay.
As is that. These were not removed. We do that.
Should I here? Where are we here? All right. So is that it, Tal? You good?
I'm all set. Yeah, thank you.
All right, perfect. Thanks. All right, let's move along. All right, so Eric, would you like to present the GX Cloud beta? All right, thanks so much, Eric. Thanks everyone for the questions, and I'm going to pass it off to Tamara from Astronomer.
Okay, now you should be able to hear me and see my screen with the presentation.
Yep, all good.
Okay, good. Not the code yet. That's on the other screen. Okay, thank you so much. Thank you so much for inviting me. This is really interesting for me coming from the Airflow perspective. It's my first time at a Great Expectation meetup. My name is Tamara, and I'm a developer advocate at Astronomer, who's the open source, who's the developer, commercial developer behind the open source project Apache Airflow. And I'm going to talk about mostly how to integrate Great Expectations with Airflow, specifically about the new Great Expectations operator. So I don't know how many of you have used Airflow before. Maybe you want to put that in the chat. I'm always interested to hear how people have used Airflow, if they just getting started or if they are already expert users. If you haven't, this is the main overview. Airflow is an open source workflow orchestration tool, often used for data pipelines, but can be used for anything you can define in Python code. It's a very popular open source tool in that space. And as you're going to see in this presentation, the pipelines are defined in Python code. Now, since I know there's probably people here at this meetup who maybe haven't used Airflow before, I want to take a quick 1 to 2 minute crash course about the most important terms and topics. The 3 terms I would like to define are DAG, tasks, and operators. So here you have 2 screenshots. On the right-hand side, you see a screenshot of the Airflow UI with the graph view of a DAG. A DAG, that stands for Directed Acyclic Graph, is how we call a workflow in Airflow. And the nodes define the tasks. So we have 2 tasks, an extract task and a write to MinIO task. And the edges, the little arrow in between, defines the dependency. So extract has to happen before write to MinIO happens. And once you have such an Airflow DAG, you can schedule it in all manners possible, maybe on a time-based schedule or when a specific event happens. There are tons of possibilities. That's the core thing that Airflow does, schedule these workflows. And on the left-hand side, you see all the codes that went into creating this workflow. The reason I added this is because a lot of people may have used Airflow maybe a year ago, and a lot of things have changed, specifically that you can now use decorators. So on line 8, you can see I'm using a decorator at DAG to tell Airflow, hey, this Python function defines my Airflow DAG. And on line 14, I'm using an add task decorator, again, on a normal Python function to say, hey, all the code in this function comprises one Airflow task. And you will see this type of notation in the demo that I'm going to show you. So I just wanted to prime you to know, hey, if we have this add task or add something structure on top of a Python function, we are creating an Airflow task with that too. The second way that you're probably more familiar with if you've used Airflow in the past to define an Airflow task is to use an operator. And an operator is just a Python class that does often a lot of things under the hood. And when you are using it, you just provide information to several parameters. So here I have an operator that I wrote for a different presentation that's just a local file system to MinIO. So I'm moving local information to a MinIO instance. And I just tell it the information, the bucket name, and the object name. So what I want the object to be named in MinIO. And everything else, all the API calls is done under the hood by the operator. And this is also how I'm going to show you you can interact with Great Expectations with the new Great Expectations operator. Okay, that was the crash course Airflow. Why am I talking to you today? We've really seen data quality is a first-class citizen in orchestration. So I've been seeing this when talking to open source users. Very quickly, the topic comes up, hey, what can I do for data quality? What tools does Airflow integrate with? What kind of operators do you have? So people really want that. But I also hearing from our field team when they talk to prospects that data quality is something that comes up in a lot of discussions. So there's really an opportunity for partnership there and a real need for people who are using data to have their data quality tools integrate with their orchestrator. And that's what's happening. There's a Great Expectations provider, which I think several co-authors are actually in this call, where a provider is what we call a collection of modules for Airflow, in this case, the operator. And as you can see, the latest release was March 22nd. So it's still being actively developed. So if there's something you want to see in it, feel free to open an issue, and especially if you happen to find a bug. And it's now on version 0.2.6, and the new Great Expectation operator was released in version 0.2.0. And before I'm going to show the operator in the demo, I wanted to zoom in and show you what the smallest pieces of information are that you need to give to this operator in order to run a Great Expectation validation. So what you see here is we have the operator. So we have the Python class, we instantiate it, we give it a task ID. This is just for Airflow to know what it should call the task in the UI. Then we give it a connection ID. This is Airflow specific. So in Airflow, you can define your connections to all kinds of other tools. And in this case, I defined a connection to my underlying database. I'm using Snowflake in the example. And then I simply have to tell it where is my Great Expectation root directory. So I'm giving it the path to that. That's stored in the gx root dir variable. And then I give it the name of the table I want to run my expectations on and the expectation suite name. Now, since you probably all even much more experts on Great Expectation than me, you're probably thinking, well, there's a ton missing here. There's no checkpoint, all of that. And the cool thing about the new Great Expectations operator is that you don't have to define those. You can if you want to. The operator has a ton of different parameters, and you should be able to customize it in any way that you need to and are used to run Great Expectations. But if you are new to Great Expectations, and if you are maybe coming from the Airflow side or just someone who's new to the space in general, this is all you need now to run a Great Expectation suite on your data from within Airflow. So it simplifies a lot of steps to make it easier for people to get started. These are the main points that are new. We can use an Airflow connection. This means people can define the connection to their data source just in one place in the Airflow connection and can use that within the Great Expectations operator. They don't have to define it in Great Expectations as well, which makes it easier to change what database you're connecting to. I'm going to show that in the demo. And it creates a default checkpoint if none is provided, but the checkpoint is still fully customizable via a parameter. And also, this was very important to do because it's not a major release. If you're using an older version of the Great Expectation operator, it should be fully backwards compatible. So you shouldn't have an issue when you're updating it. Okay, those were a lot of words and slides. Now I want to show you what this looks like in a small mock pipeline. I made a little ELT pipeline using energy capacity data of some European countries. And I want to analyze it. And what I was thinking was, I want to use Great Expectations to check my data quality. And for all the other steps, I'm using a different package that's built on top of Airflow called the AstroPython SDK. This is also open source, so fully available for you. And it was built by a team at Astronomer. And you will see why I'm using it, because it makes a lot of steps a lot easier, especially loading in files and using pandas on relational data. Now with that, let's hop over. So in case you haven't used Airflow, this is the Airflow UI. I'm running locally here. And I have one DAG here running. And if I click on it, I have the graph view. This is the same view I showed earlier with just the 2 tasks. But now we have a little bigger pipeline. We have 5 tasks in this DAG, and one which is a little special. It runs on the side here. It's called cleanup. This is a special task that will, in the end, clean up all the temporary tables that I'm creating. So this is here, so the DBA is not mad at me at the end of the day. But the actual pipeline is down here. We have a load file task. So we're first loading a file into our database. We're running a very simple transformation on it. And then I'm using the Great Expectations operator here to validate my data, running one expectation on it. And lastly, if that validation passes, so if all the validations are correct and my data is the way I expect it to, and the transform task, of course, also has to be successful, then I'm running my analyze function. And now this DAG could be scheduled on any kind of cadence or on any kind of dependency of events happening in other data tools. Now let me hop over into my code. You should now see my VS Code. And what you're seeing here, I will not go into detail in all of the folders and files here because probably that would take a while. But this is an Astro project, so it's an Airflow project that was created using the Astro CLI, which is also open source. And the important things to note is we have a Docker file here. So we're running Airflow within Docker. It's the Astro runtime, but this is equivalent to open source Airflow. And we have a requirements file. So I'm installing the packages that I need in my Airflow environment. I'm installing the provider package so I can use the Great Expectation operator. I'm installing the Astro Python SDK, and I'm also using scikit-learn. And apart from this, the only things that are interesting right now is the include folder and the DAX folder. The include folder is a folder that will automatically be hosted in the Docker container. So anything you put here will also be in your Docker container and available to your DAX. And the DAX folder will contain your DAX. So the first thing I want to show you is where does the Great Expectation project go if you're using it with Airflow. You can initialize it within the include folder. So we have the Great Expectation project here, and this looks the way that all your Great Expectation projects usually look. What you will notice is I don't have a checkpoint and no profilers. So I just initialized this and I added one expectation suite. Very minimalistic, just with one expectation that runs on the result column of my transformation. But I didn't define anything else. I simply just created this JSON file. And I also didn't define any data sources in here. And on the DAX side, I will not have time to run through all of the code here in detail, but the repository where this whole project is stored is public. So I'm going to put the link to that into the chat after the presentation. But what you can see here is I'm importing the Great Expectations operator. I'm importing some tools from the Astro Python SDK. I'm setting all of my variables up here. And then I define my tasks. So if you remember, I showed you that we now have decorators that turn Python functions into Airflow tasks. So what I'm doing here is I'm saying I have a SQL statement here, and I want this SQL statement to be packaged into an Airflow task. So that is transform energy. I have an analysis script that I want to have as my analyze task. And down here, I'm defining and building my DAG. So here is the DAG decorator, which means everything in this function will be an Airflow DAG. First, I'm going to load my file. And now you see why I like using the Astro Python SDK for this, because I have my file stored in the include folder here. And I just have to point this operator at the input file. So I'm telling it the path to this file and the connection, which is my local file system. And I'm telling it the output table, which is my Snowflake database, and the schema here, because I only have my own sandbox schema. But apart from that, I don't have to do anything to create this table in my sandbox. So from a CSV file to a relational table in 3 lines of code. And next, I can actually use this object to be referenced in my transform function and run the SQL transformation on that, and again, store the output in a table. And now I have my reporting table that I actually want to run the validations on. So I have my report table name, which I'm giving to the great expectation operator here. I give it the same schema that I'm using up here and the same connection ID. And this is one of the reasons why people like integrating their data quality tools, and especially great expectations with Airflow. Now, if you would ever change, for example, the database that you're using, for example, between dev and prod, you would only need to change your connection ID that you're providing here once, and then it would change both where the whole pipeline runs, but also where the great expectation operator is aimed at, just with one variable change. I give it the root context, so I'm pointing it at that file, and I'm giving it the name of my expectation suite. And lastly, if this passes, this is how Airflow sets dependencies. I'm saying only if transform data is successful, run the validation task, and only if the validation task is successful, run the analyze task. And lastly, cleaning up. So database administrator isn't mad at me. I realize that might have been a little quick because of time constraints, but the repository is public and you can look at it later. Now let's run this DAG. This is just creating a manual run, and it takes approximately 1 minute to run fully. So the task that actually takes longest is to load the CSV file into the Snowflake database. You can see here the whole connection. You can see that a temporary table is created that I don't have to worry about because I'm just referencing it as a Python object. Then I'm running my transformation task. Can actually double check here what the SQL query is that actually goes into this task and what the parameters are that are rendered at runtime. And my great expectation validation also ran. It is successful, and as you are used to, your Datadogs documentation will be generated in your include folder in your great expectations root folder. And lastly, I ran the analysis task. If I scroll up here, you can actually see I just fitted a regression line to the percentage of renewable energy capacity. And for both, I did it for France and for Switzerland. For both, it was positive. So both France and Switzerland have upped their renewable energy capacity between 2010 and current data. So that's kind of what we want to see here. And I will not go deeper into this because of time, because I have one last thing that I want to show you. This was all open source up to this point, and it's free for you to use. But I also wanted to show you something that the Astronomer team has been working on in our cloud offering. So if you've never seen it, Astronomer is offering basically Airflow hosted in the cloud. And one of the tools that we started to create here, it's still under preview flag, so under active development, is called the Cloud IDE. And this is basically, you have a notebook style interface to write your Airflow DAGs. So the idea is, how can we help people who don't know about Airflow and maybe don't want to learn about all of the syntax to write Airflow DAGs in a notebook style environment. And what's happening here is that you can add cells, as you saw before with the decorators, but now you only have to worry about writing the SQL, like up here, or writing the Python. And if I run this, it takes a second, but you can actually see the output of the file, as you're probably used to if you're working in Jupyter Notebooks and other notebook style systems. And the cool thing is that that's pretty new is that you can now, when you add a cell, specifically add a great expectation operator in this environment too. And then you get a whole cell with all the parameters that you can give to this great expectation operator. And you never have to worry even about writing Python code, because under the hood, it's of course still all code, and the Python code is automatically generated over here. And you can see here the great expectation operator. I'm using the same parameters basically as in the demo earlier, is generated. So now you have an Airflow DAG that you can download or commit to a GitHub repository without even knowing anything about Airflow. Yeah, so that was very quick because I'm mindful of the time. But one of the most important things, the credit doesn't go to me at all. It goes to the people who actually built this operator, especially the new version. So Benji, Tal, and Caxel were the three main people involved. But of course, many more people who contributed to it and are still contributing to the Great Expectations operator and provider. And of course, the Cloud IDE, massive props to the Cloud IDE team who have built that over the last few months. Yeah, and lastly, if you want to learn more about Airflow, we have an academy, we have a lot of Learn documentation. And if you're interested in having a look at the cloud offering, you can now start a free guided trial. Yeah, and please tell us how that is working because that's very new. But then you can check out the Cloud IDE too.
Amazing. Thanks so much.
Thank you. I
Yeah,
hope I
well
was
done.
okay in time.
Yeah, that was great. Super efficient. Thank you so much. And just for there's you definitely have some questions in the chat, and I think they're looking forward to getting their hands on your resources for the presentation. Also, we have a Slack channel in the GX community for the operator. So I'm just going to double check. For some reason, I'm forgetting what it's named.
Yeah. I'm
What's the
going
name of
to
that channel
put the
again?
GitHub repo link
Oh, yeah.
in the chat in the meantime. I think
Cool.
that's the main thing probably that people were asking about because I was way too fast over that code. No chance to.
Yeah, check that out. And then also in the channel Integration Airflow, feel free to ask more questions. Tamara will I'm sure in the Airflow team or the Astronomer team will see it as well, along with our team. Yeah, so thanks so much, Tamara.
Yeah, thanks for having me.
Okay, I am going to pass it off to Ruben, the
Hey.
last section.
Oops. Hey, hello everyone. So I'm going to, as soon as I get my screen figure out here, okay, and then, all right, perfect. So can you see my browser right now? Hello?
Yep, I
Okay,
can see
good.
it.
And then, all right, so yeah, this is a new section that we're trying this week. It's called Common Questions Answer, where we looked at some of the questions that are commonly asked in our community Slack. And then we decide to pick one or several of them that deserve, further discussion or ones that we can give advice on, right? So the ones that we decided to speak out about this week is basically, like this comes on and off again. It's about having an official Docker image. Presently, we do not, we have a Docker image, but it's not suitable for many use cases. Some people have difficulties with it, whether they can containerize it or how they can customize it or et cetera, right? So like but I guess with good news is the fact is that you can do this yourself if you have Docker. Hello? Yeah. To build images. And then basically, so we have several use cases that I will show you. Is that basically this is that how to use Docker for local development. And then here's where I'm going to go to my Visual Studio Code. So like I'm going to show you how to define the image to build. And then as you can see, it's fairly easy here, fairly straightforward. You import from Ubuntu or whichever image your organization has. It can be Alpine or any other distribution or base image that you are comfortable using. And then we are going to, here line 4 is just basically telling the image to go ahead and burn the requirements in order to install Python and the pip, and as well as Great Expectations later on, right? So up until here, right, this is our just basically essential requirements. Once that's done, then we're going to go ahead and tell pip to install Great Expectations. And again, from here, it really depends. You can have brackets like Snowflake or whichever sub requirements that you need. This can be done from here as well, right? But just for the sake of this demo, I'm simply choosing to have the plain vanilla Great Expectations. And then I'm going to tell the Docker image builder to create in that container a a work directory called app, and then the work directory, the way it works in Docker. So if you don't know, is that it basically is going to be your landing site once you go into that container, and things that run will be running out of that particular directory unless otherwise specified. Okay, so then we're going to go ahead and tell the Docker to build that image for us. The command, I just posted on the screen. It builds the image. Obviously, assuming that, if this is because we have cache, but normally will take a couple of minutes to build. And then we're going to go and log into that particular container just to show you, right? We log, and then we are going to land in the apps directory. If you're seeing in my terminal at the bottom of the screen, you can see that we landed there. However, there's nothing there. So, it's not a particularly useful thing to do. So one of the things that we can do for local development is essentially we're gonna, we can mount our local directory into the container, and then mount it in that particular work directory. So that way, when we run it, right, and then we do ls, we're gonna have access to whatever files we have here on the left, in the left nav bar that you can see. They're gonna be also accessible for there. And then if you were to make a change to this file, for instance, like that, this is my change to my local thing. And then if you were to look in the container itself, then you can say that, like it's written right there. And then so you can keep working and then running things here locally. I mean, working here and then running things directly in the container. For instance, like you can even do run the Python script with a demo sample. I mean, let's assume that this is your expectations code, and then it will run, right? Like it just whatever you have defined in that code, all of this is running in the container, even though you can be modifying the files locally. That's all cool and all, right? Like, and then just very useful as you're also developing, if you're planning to eventually deploy this particular container to a CI environment or a CI pipeline. And then, but then let's say that you are in a restrictive environment where like you're only given access to a browser and a Docker runtime, assuming your organization has everything else, right? So like we can come here, for instance, and then we can add this this command line, this line, as soon as I copy it. And sorry, excuse me. All right, good. So we grab this command over here, and we save it to the file, and then we're gonna build again. Right, and then once the image is built, then we're gonna go ahead and tell Docker to run the container, and then we're gonna use port forwarding. So that way, when that runs, this is running the container here at the bottom. And then if I were to click this one over here, then I have a fully functional Jupyter notebook that is running in my browser. It's running the container. I can see it through the browser. And then, for instance, like I can see it through here, right? Like, and then assuming that you have your GX code, this is all being executed at the container level. And then, like, again, like you can continue on and work as if it was local. This is all running in the, you're simply using the browser as a way to do that. Just really cool. Okay, so going back here, so let's talk about a different, so once you're ready, let's say to, submit, not to submit, to have this particular container to be part of your CI, then we're gonna go ahead and let me go and then show you here. We're gonna go ahead, close these two tabs and leave, there you go. And then, like what happens, let's try to tie all this together. It says like, well, let's say that you have GX for team development, you have a repository that you want that repository to be tested. Right, and then like, so this is a very common use case, and I would say one of the most useful ones. So then the way that we're going to do that is if we look right at the definition for you to build your own image for that, it's going to be a nearly identical up until here. The only difference that we're going to install curl and git as part of the requirements, And then this will allow you to then to check out all the components or clone the repos that you want. So let's assume that you have a trigger to your CI, right? Then it's just like, well, when these files are updated, trigger that pipeline, and then this will go ahead and then run this. It will clone it. It will clone the project in the current directory, and again, the current directory is going to be definition, but because of the facilities that Docker gave us, it's going to be the app. And then once that builds, that will remain there, easy and access, and then we're going to run a PyExample script directly here. So that way, after the CI builds and then it runs that container, then it will show here, obviously here, this is just the same file that I run before, but you can have your tests defined here, your expectations defined. And further, if you have other stuff set up in your GX right project, whether it is like notifications to Teams or Slack, or whether it is posting your data docs to a cloud hosting, all of that will get done, right? And then eventually, once that's done, the step will show us whether succeed or failure to the CI, and then should be able to take other steps beyond that, right? So again, it's with that Docker file image, we're gonna, oops. Let me copy and paste the command, and paste. All right, so we're gonna tell it to build that image for us, and then we just basically tell it the CI will have the trigger to run that container. Oops, and of course that is not really command. And then that's it. So like it will, the files are already burned into the image, and then you will run whatever script or scripts that you want to run, and it will have it there. So like, I think all this to say, right, like as I've told you, it's like a relatively fairly straightforward, simple to create an image of your own for your own custom usage. Great expectations, there's nothing magical, nothing special about it. You can download from pip, and add or remove whichever like requirements that you need. All right, and when with that, right, this is a fairly, like a topic that has come up on and off again. Let's keep this conversation going, right? Like in the community Slack, I'll be watching for in the data-quality-discussion channel. And then if you have any suggestions or, or any other queries around that, I'll be happy to answer them in that channel. And with that, I'm going to pass back to Kyle.
Thank you, Ruben. That was incredibly efficient. Got us in with only two minutes over time. Thank you very much. Thanks everyone for coming. Thank you for all the great questions and participation. Thanks Tamara for joining us today. That was awesome. So if your questions didn't get answered, please jump into those Slack channels and we'll get to them. All right. See y'all next month.
Thank you.